you just reduce the domain size as a half of the original size. So the code rate here is smaller than the code rate fry. So if you have a smaller code rate, you can make like fewer queries, and if you make fewer queries, you can get a like smaller pool size. And if you have a smaller pool size, you can get the like least verification cost. And so this chart is from the paper stir, and this show the performance comparison between stir and fry. And we can find that the stir has the least argument size and least verified hash. And it also has the least verified time when the polynomial degree less than 2 to power 24 power of 24. Yeah. So what this means? This means that once we achieve a smaller pool size, we may be able to have a smaller verification circuit, and which could make the recursive proving process faster. Like as we know, SP1 they have integrate PLUNKET3 as their proof system, and if we can integrate stir into the PLUNKET3 repo. So SP1 just need to like write the recursive circuits use their like DSL something circuit tool to write the circuit. Yeah, and it can make your recursive prover faster. Yeah. This is our plan. That's something we need to finish. The first thing is understand the stir paper and code. This is finished now. And decide the low degree test trait for PLUNKET3. This also have been done. And we are working now is that support the K degree folding feature for PLUNKET3. And this work will be finished in this week. And the rest of the work is integrate stir into PLUNKET3 will be finished within 2 weeks. And the last thing is that we need to like implement a verified circuit for the stack based on stir to recursive, and we will do this work like use the SP1. They have a DSL to write the recursion circuit, and we will do this work and try to integrate this work into SP1 repo. This is some detail about how to integrate stir into PLUNKET3 repo. As we know, PLUNKET3 they reduce the problem that proving every program into like do low degree test for the polynomial f. And now they only support fry to do low degree test. So what we want to do is that we want to support stir as another option to do low degree test. So the question is how to we need to design the low degree test trait into PLUNKET3, and we also need to make sure that the fry and the stir the fry from PLUNKET3 they have implement they need to implement this trait, and the stir we try to implement also need to implement this stir. And this means that once this work and the stir integration is finished, any stack in PLUNKET3 will be able to freely compose with either stir or fry, and as their low degree test function. That's what we want to do in Visual Garden. Okay. Thank you. And you maybe can check some code from this repo, but we also need much work need to do in the future. Yeah. Okay. That's all. Thank you.
Hello everyone. My name is Steve, and what I'm bringing here today is Abstract, which is a layer 2 ZK rollup. Sorry, yeah. So first, what is Abstract? It is a layer 2 ZK rollup blockchain built on top of the Aptos, which is the layer 1, and it uses the StackNet tech stack, and specifically we use Maraza as a project that we use as a base one. So why we building this? First is that no one has built this on Aptos before, and the second reason is that we want to learn how to build a layer 2 ZK rollup from scratch, and the final goal is that we want to create like after like learning how to build a layer 2, we want to make it optimize this for like gaming for games that requires high throughput. It's like a layer 2 building layer 2 app. I'm sorry, layer 3 app chain. But that's like in the future. So this is like a full flow and the the whole architecture of the services inside the Maraza. But I won't dive into this here. You can like check out this diagram and the explain about just by scanning the QR code or like to view it. So for now we about our progress. For now we have like written the equivalent verifier smart contract function written in moves like it's like mostly completed, and about like the Maraza orchestrator code, we have converted it to like working with the Aptos instead of Ethereum, about like 90%, and about the Maraza repo, we have like integrated it, about like 50%, and right now we are in the deployment progress, which we have like deployed a layer 1 Aptos network, and the layer 2 we also deployed, but the remaining part is like connecting the layer 1 and the layer 2 with each other, which is like what we are doing. So you can try interact with our layer 2. You're using this RPC arrest here, and you can like view the transaction and blocks by using the Explorer. And that's all for me. And thank you for. Please.
Why did you choose the StackNet tech stack?
Because it's. I think that it's first it use Stack, which is what we want to like learn deeper, and the second is that we use Maraza, which is like a modular project that we can like switch out the Ethereum part to out the Aptos part, so that the code can change the layer 1.
You say Madara, the Ethereum part of the Aptos part. Which part do you have to swap out?
So this is like our layer 1. But the Madaza project originally support Ethereum instead of Aptos. So we want to change the Ethereum part to the Aptos part. Yeah. Yeah, thank you.
And the final one, approve of visibility. Next Friday, okay? Because it's like yeah, but you have next Friday. Please. Yeah, but this is already the schedule was like we weren't expecting. So next time we'll probably split between morning and night. It's okay. You can present next week. Okay.
How many minutes?
Why do we have this?
It's for the recording.
Okay, thank you so much for waiting patiently for us. All right, so 2 weeks ago we proposed the idea of having a proof of invisibility, which is the ability to prove that you went to the office or went to an event without anyone actually knowing that it was you who came to that event and when you came and when you left. So no one has their beady eyes on you. And so we want to build this decentralized, almost invisible attendance system. So our original name was called a decentralized event network node for intelligent supervision. We call this Proof of Invisibility 1.0, and it was known as Dennis. However, I've heard that Dennis got fired. So we've upgraded our system to Proof of Invisibility 2.0, which is known as a masked identity check-in with cryptographic knowledge yield, also known as Mickey. Let me explain what Mickey is. Mickey is a privacy-preserving automated check-in system. So you go to the office or an event, and you are able to check in or verify yourself that you actually attended, but no one actually knows like it was you or when you came in or where exactly you were. But you are meeting the requirement of your work or the event or in a verified way. So we want to be able to track the attendance using ZK proofs, so everything is private. And so we have we have three key components. The first is that we're going to use geofencing so that you are in a physical place using your mobile phone, and we're going to verify people using a Telegram bot, which is basically a mini app, like a mini app inside Telegram. So you can actually just click a button in the bot, and the bot can actually notify you if you're late or you're going to be facing a problem. But it's not the organizers doing it; it's the bot doing it. So you kind of like not being ashamed by your boss or someone else. And we use ZKPs to ensure that the attendance is recorded without revealing any personal data. So we looked at several verification methods. We had a long discussion. There's Wi-Fi verification, there's NFC verification, like tapping your phone on something, or we use GPS. There's no perfect solution, but we went for GPS because it's the simplest one. Wi-Fi verification isn't really possible unless you have a native app on your mobile phone, so we got rid of that. NFC requires hardware, and what if the hardware is like broken in some way? We just want to remove every kind of form of complication. So you just need your mobile phone, enable your location, and you're able to check in. And in terms of ZKPs as well, we are beginners. We're newbies at this. We don't really know what we're doing with ZKPs in terms of actually writing them. But if we go like the very hardcore way, which is actually to use write our own circuits, our own snarks, it's completely like customized. It's perfect for actually writing for a solution like this, but it's too complicated for us, quite frankly, and it requires a server, a lot of computational resources, and we don't really know what we're doing, so we don't want to get into this deep solution and get stuck. So we looked at frameworks, and one framework we looked at was ZK Shield. How is it moving? What the hell? Are you serious? Wait, I have an idea. Hold on. I'll go to the one sec.
You can paint the slides.
I got it. I found it. Come. Did it appear? It's behind me? Good. So the second solution was to use a framework called ZK Shield, but this also is not very well adopted and has very, very limited use case. So we went for something, we looked at the PSC website, and we found that they've actually built an amazing project called Semaphore. And so this allows you to prove that you're part of a group, which is exactly what we want. We want to prove that you're actually a valid employee or a valid workshop member. So it's actually ideal for what we want. And so it's quite lightweight, quite modern. And what we actually specifically want to do is generate the proof on the mobile phone. And we think we could do it with Semaphore. So our overall solution is to combine Semaphore, geofencing, and generate the proofs locally. And so we're able to verify the presence within a certain location using GPS. Semaphore allows us to generate the proofs locally on the trading bot, and we estimate that the time will be around 5 to 10 seconds on a fairly newish mobile phone. And this allows us so that when we actually submit the proof to the server on the back end where the admins are, there's no sensitive data going to the server, and it stays private. The bot is able to send notifications depending on your status, saying well done, you're on time, or no, you're getting late, hurry up, the check-in time is about to close. Everything's automated. So the check-in flows at the GPS location is validated locally. If you're within the geofence, a proof is created and sent to the server for verification. Do you want to take the next one?
Okay. Oh. Okay. So this one is finished. Oh.
No, you go ahead.
Okay. So this is our technical design. Actually, the front end we will use just the BioSci like inside TGBot application, and actually it's just a click button at the HTML5 page, and then send the and generate the proof and send the proof to the verification. Then at the back end, we verify the ZK proofs and then recorded the attendance, and then send the attendance record to the IG admin to the staff. So that's what to do. Maybe you keep.
Do you want to say something?
No. Maybe you can finish and then we answer the.
Okay, so the reason we chose Semaphore is that the way it works is on your mobile phone you create a local identity, and then that identity is formed of a key pair, which is one is public, one is private, so you only share the public one. And then in terms of geofencing, it's actually possible that that's actually public information, but no one knows that geofencing information is yours, because two things are sent. One is your identity and one is the geofence information, but no one actually knows it's yours. So we're looking at to see how we make that more private. The first version is your identity is private, and the second one is everything is private. In terms of proof creation, we believe we can actually do it on the phone. This will be an interesting experiment next week that we're going to do. And you're able to prove that you are part of that group. And so if you're not part of the group, you'll get a notification saying you've been kicked out of this workshop. Sorry, please go away. So the proof is actually sent to the server along with the public signals, i.e. the extra data. So we're using Semaphore. And to be very frank, we are an application team. We're not building infra here. So I think most of the teams here are like trying to implement very hardcore ZK circuits and stuff, but we're thinking on the user side, how can we build something cool and interesting and useful, but then implement ZK privacy into the solution. So we're happy to answer any questions if there are any. Yes.
So I have a question. As a user, because usually the attendance is between a range of time, do I need to have my GPS on for the whole time? And what happens if I lose battery on my phone?
Yeah, this would assume that your phone is going to be online, which I think is not a bad requirement nowadays. There's a lot of places where you need a phone to be on all the time to get in. Phones are commonplace. And regarding GPS, no, only when you check in. You can turn it off afterwards.
But then I can just go away.
Yeah.
And no one. So
Yeah, but we can take, like, if that was a requirement, like for this version, we just do it for the check-in. So yeah, but it is possible quite simply to have it on all the time, and then every so often it kind of automatically pings the server or something like that. That's also possible. But for the sake of simplicity, yeah, just to answer your question, like, for now you can turn it off. We only have one check-in a day. That's our current business model, which is what we're doing over here at the moment. But yeah, it could expand. And to answer you another preemptive question, can you spoof the GPS? Yes, you could. But what we're going to add in is, are you connected to a Wi-Fi? So you're not walking on the street, you're actually connected to a Wi-Fi. But we can't get the SSID using a HTML5 app. Again, we have a lot of constraints. So there are, like I said, there's pros and cons. So we know that we know you're connected to Wi-Fi, and we know that you're in this GPS locale, and for that, that's good enough for us. So unless someone rooted their goddamn phone and like spoofed the GPS, but that's too much right now. Yeah. Yes, Anderson. A QR code? So there's two ways of QR code. We discussed it. One is like the organizers print out a QR code. Another one is they have like a tablet and the QR code refreshes like every so often, but then it requires the organizers to do something. So we don't want the organizers to do anything. Get rid of them. The user is able to do everything themselves.
What I don't quite understand is like the proof submissions. The proof is being sent to like your own server. I'm not super familiar with Semaphore to be honest, but like,
Okay.
why, like your own server, like why do you install even a proof? You don't even need to necessarily store it, right?
Well, the admin has that in interface as well. So the admin is able to see that how many people attended today, but they don't know who it was. So they have an idea of and automatically, if someone's not attending on time, they get kicked out automatically by the system. So the admins at least know what's going on. But they don't know who and when they came.
I guess just what I'm thinking of is like, for example, if your application goes down, Optimede is a way to still, run it without you having to release your own stuff. But I mean, that's like, for example, if you have to prove and directly verifies the chain, I mean, why would you?
And then you'd ideally have a decentralized infrastructure, so the application lives. Yeah.
I think that's at least if that's the ambition, that'd be nice.
Sure. Sorry, say again. Uh-huh. Okay. All right. All right, appreciate it. Okay, we'll do that.
Thank you.
Yeah, I remember somebody else actually posted some frameworks and some ideas before as well. I think it was you. Was it someone else? It was you, right?
Yeah. And then
Yeah.
there's IFC solution.
Yeah. Okay. Okay, thank you so much. Let's go out and have some fun. Thank you so much. Oh, you want to speak?
Yeah.
Oh, I thought I was the last one.
Yeah, because I just added in the last one.
Cool.
Why do you do like an HTML5 app? Because you don't have like a Telegram app?
Yeah.
Not okay.
Yeah.
Yeah. The alternative is like a web app. Like not even an app.
HTML5 is a web app.
That's web app pretty much.
Okay. Does it work? It doesn't work?
It works just for the streaming or for the video.
Okay. So hello everyone, my name is Qin Hao, and we're building a system called ZK Code, and actually it's doing the thing like to prove your code contributions in some private code base. And why we are doing this is because I have presented my original ideas for two times, and we built a system that basically doing the tracking, automatic tracking on GitHub to try to record every open source contributions, and we want to reward all the contributors based on the contributions. And and so sorry for the last minute. I just added my project because the whole idea is just come up, and our original idea is not that aligned the sponsors' requirements. So still I need to first explain our original system how it works. Like we treat all the GitHub issues as some task, and we see if someone has contributed a lot, means they have opened some pull requests and close a lot of issues. And if they close more issues, they should make more contributions, and we think we shall reward them more. And the whole system works like this. Actually, we add a webhook to GitHub service, and if there are any actions happening in the GitHub, our service will be notified. And the thing is our service will record all the contributions on-chain through a smart contract. And that's the whole system, how it works. But there is a big problem is how to record the contributions on-chain. Currently, we have a centralized service, and it has a superpower to record it because we don't trust anyone. If the smart contract can be recorded by anyone, we don't think there might be some cheat. But this make our system is actually not that decentralized. And all the time I'm thinking, how can I solve this problem? Usually, this kind of problem is solved by an Oracle service, but currently there is actually no Oracle service can subscribe the huge amount of data like GitHub, and actually not many people care about it. So how can we do it decentralized? And thanks for all the tokens like the Dr. Guo and the ZK emails, and it inspired me a lot, and currently we have a new solution for it. The first is a good thing that every GitHub commit, actually you can sign it. And so that if the contributor he reveal his public key, so that the contract can use the public key to verify the contributions. So the problem solved. But if the contribution like the repo is a private one, or the user just simply don't want to reveal his username on-chain, because if you write it on-chain, it will be public to anyone. So that's a problem, and we think ZK can make it work. And so let me show the demo we built, and it already worked to prove our concept. Like I have already provided a GitHub repo to showcase our ability, and you can see there are some commits here. and all the commits are actually already signed by a private key. And the first thing in our system is like you can fetch all the commits. It's not that useful because our focus is on the private